Hi everybody! So today we're going to be doing notes on section 6.6, which is solving radical equations. So go ahead and pause this and write this all down. All right, so first I want to go through the steps. Step 1 is to isolate the radical. What does it mean to isolate something again? If you said something along the lines of get it by itself, then you are correct. Get it by itself or get it alone, etc. Step 2, raise each side to the power of the index. Remember, the index is that little teeny tiny number in your radical, out in front of the radical. Step 3, solve for x. And then last but not least, we need to check for extraneous solutions. And remember, extraneous solutions are when we solve it and we get, okay, say x equals blah, blah, and blah, blah. So they look like they're real answers, but then when you plug them back in, they don't actually work when you plug it back into the original equation. So we're going to have to check for extraneous solutions for all of these problems. Let's look at some examples. So, part A, step 1 is to isolate the radical. What do you think we do first to isolate it? If you said subtract 9, you are correct. So I'm going to go ahead and show that step. So I'm going to subtract 9 on both sides. And then we get 5 times the cube root of 2x equals 20. What do you think we do next? If you said divide by 5, you are correct. So my radical is almost isolated. So then I'm going to have the cube root of 2x equals 4. Now, the next step is to actually get rid of this radical. So to do this, we raise each side to the power of the index. So I'm going to raise each of these. And what is my index for this problem? You should have said 3. This little teeny tiny number here, that's our index. So when I raise the cube root to the third power, what that does is it cancels out the radical and then gives us just 2x. So that's the goal. That is why we raise it to the power of the index. Equals, now 4 cubed is 4 times 4 times 4, which is 64. So my final step is to divide both sides by 2, and we get x equals 32. But remember, we need to check for extraneous solutions. So that's what I'm going to do. I'm going to check. Now I only have one solution to check, which is nice. I only have to plug in one number. So in the original equation, I'm going to have 9 plus 5 times the cube root of 2 times 32, which is 64, equals 29. And I'm going to simplify this. So 9 plus 5 times the cube root of 64 is 4, equals 29. So 9 plus 20 equals 29. I can go ahead and stop there because I see the left side is equal to the right side, so I'm good. Which means x equals 32 is in fact a solution. Let's look at part B now. What do you think we do first? If you said raise each side to the second power or square both sides or anything along those lines, you are correct. So my radical is already isolated, which is super nice. And my index here, since there's no number written, that means the index is 2. So I'm going to square both sides. And that will cancel out my radical. So then I'll be left with 90 minus x equals x squared. Now, for this one, when I look at this, I see I have a constant, an x, and an x squared. Seeing that I have an x and an x squared shows me I'm going to have a trinomial, and the best way that we know to solve those is by factoring. So I'm going to get everything together all on one side. So I'm going to subtract 90 to move it to the right, and I'm going to add x also to move it to the right. So I'm going to end up with 0 equals x squared plus x minus 90. Now from here, we can do the big X. What goes in the top and bottom? You should have said negative 90 and positive 1. So what are my two numbers? You should have said 10 and negative 9. So 0 equals x plus 10 times x minus 9. Now from here, all of this is review. So this section is going to bring in prior knowledge from a lot of different other units and sections that you're going to have to apply to solve these problems. So each of these multiplied equal to 0 means I can say either x plus 10 equals 0 or x minus 9 equals 0. So then when I solve each of those for x, I get x equals negative 10 and x equals 9. But what do we have to do before we highlight our answer? You should have said check our answers or check for extraneous solutions, something along those lines. All right, now because I'm checking two different ones, I'm going to label them just so I know which one is which. So x equals negative 10, I'm going to do that one first. So I'm going to have the square root of 90 minus negative 10 equals negative 10. So this will be the square root of 100 equals negative 10. So 10, that does not equal negative 10, which means negative 10 is not going to be a solution that works. But we still need to test the other one, because it's possible that either neither of them work, both work, or only one will work. So you always have to check both. So x equals 9. Square root of 90 minus 9 equals 9. So this is the square root of 81 equals 9. So 9 equals 9, which is true. It works. Which means x equals 9 is our only solution for this. X equals negative 10 was extraneous. All right, let's do another one. This one is a little bit different because we have a radical on both sides. However, both of these radicals, what is the index? If you said 4, you are correct. They both have an index of 4 and they are both isolated, which means we can go ahead and just raise both sides to the 4th power. And it's going to cancel out my radical on both sides. So then we'll end up with 3x plus 3 equals 2x minus 7. Now go ahead and push pause and finish solving for x, and then push play when you're ready to check. All right, you should have gotten negative 10. Now I did this all in one step, getting my x's by themselves on the left and moving the constant over to the right. You may have done it in two separate steps, which is totally fine. All right, but we still need to check this. So I want you to go ahead and do this on your own. Push pause, and then when you're ready to check, push play. All right, go ahead and check what's written over here in green. Now, although we can't simplify either of these things any further, the left side and the right side are equal to each other. They are equivalent, which means this is an answer that works. It is not extraneous. All right, let's look at part B. Now, this one is a little bit different. They're both a square root, but no matter what we do, we will never be able to isolate the radical on the left side and the right side at the same time. This one is always going to be in the way, no matter what. So I'm going to write a little note about that. It is not possible to isolate both, zoom that out a little bit, not possible to isolate both radicals. So make sure at least one is isolated. And you'll see why in a second. So if it is absolutely not possible to isolate both, make sure at least one of them is. All right, so right now, one of them is. The one on the right side is isolated. So what I'm going to do is raise both sides of this equation, because we have to do the same thing to the left and the right. Raise both sides to the second power. Now with the right side, that's going to cancel out my radical. But the left side, not quite. So we're going to treat this just like any other binomial that we had squared. And I'm going to rewrite this as the square root of x plus 1 times the square root of x plus 1. And that's equal to x plus 5. Now from here, we have a binomial times a binomial. So what we can do now is FOIL. First, outer, inner, last. Because we still need to be able to isolate the radical to solve this thing, and right now I have two radicals. So when I multiply this, first, square root of x times square root of x becomes x. Square root of x times 1 is the square root of x. Inner, 1 times the square root of x is the square root of x. And then last, 1 times 1 is 1, equals the x plus 5. So now I'm going to combine like terms. So x plus 2 radical x plus 1 equals x plus 5. So now in this step, now I only have one radical left. I need to isolate this radical. So what do you think we need to do, specifically like math operations? What do we need to do to get that square root by itself? If you said either subtract the x or subtract the 1 from both sides, or if you said subtract x and 1 on both sides, that is correct. Now I'm going to do those both at the same time. I'm going to subtract x and subtract 1 from both sides. If you want to do it in two separate steps, that's totally fine. So I'm going to have 2 times the square root of x equals, now here, x minus x, they go away. I'm left with just 4, so that's pretty nice. What do I do last to isolate my radical? You said divide both sides by 2, you are correct. So we're going to have the square root of x equals 2. And now my last step is to square both sides. And that square root and squared are going to cancel each other out. And I'm left with just x equals 4. So we essentially had to go through that process kind of twice. The blue part up here where I squared both sides, and then the blue part down here having it isolated, etc. We essentially had to do the process twice. Now we do still have to check. So plug in 4 into our original equation. So the square root of 4 plus 1 equals the square root of 4 plus 5. Go ahead and simplify that and then push play when you're ready to check. You should have gotten 3 equals 3, which is true. So it works. It is a solution. All right, let's do one more of these. Now this one looks a little bit different because instead of having an actual radical symbol, we have a rational exponent. But we know from earlier in this unit that this can be rewritten as a radical raised to a power. So in other words, this is the thing that we want to isolate. We want to isolate this. So to do that, we need to add 3 to both sides. Then we will end up with 2x plus 12 to the 2/3 power equals 16. Now notice that when I write these, I leave space between them and the equal sign. I do that purposefully because I know I'm going to have to draw in extra parentheses and raise stuff to powers. And I just don't want it to be super smushed on my paper. All right. Now, this was the thing we needed to isolate, which means this is what's going to get raised to a power. But we don't have the index written in terms of just having the square root. So what we do here is raise each side to the reciprocal power. Now, do you remember what reciprocal means? If you said something along the lines of you flip the fraction, you're correct. So right now it's 2/3. So to raise it to the reciprocal means we raise it to 3/2. And then that 2/3 and 3/2 will cancel out. And the left side, I'm left with just 2x plus 12 equals, now this, 16 to the 3/2 power. This brings in our knowledge from earlier this unit where we have to rewrite this thing as a radical so that we can simplify it. So is this going to be the square root of 16 or the cube root of 16? If you said the square root of 16, you are correct. It will be the square root of 16 raised to the 3rd power. Because remember, the number on the bottom is the index. The number on the top is the power. And if you have trouble remembering that, pull out your notes from earlier in this unit. All right, so now we need to finish simplifying this. So 2x plus 12 equals, now I'm going to do this work over here off to the side. The square root of 16, just because I'm running out of space on my paper. The square root of 16, remember when we do these things, we have to write this as plus or minus 4, and that's raised to the 3rd power. So positive 4 to the 3rd power is 4 times 4 times 4, which is 64. But then negative 4 to the 3rd power is negative 4 times negative 4 times negative 4, which is negative 64. So in other words, this thing is equal to plus or minus 64. Now again, I chose to just do this part in pink over here because I'm running out of space on the paper. Normally I would have just written that here and continue drawing my, my rows going down. All right, so since this thing is equal to plus or minus, that tells me we need to set up 2 equations. So I'm going to have one where it's the 2x plus 12 equals positive 64, and then another option where it's the 2x plus 12 equals negative 64. So both of these we need to solve. Go ahead and push pause, finish solving each of those, and then push play when you're ready to check. All right, go ahead and check your 2 answers. But what's the last thing we have to do before we can highlight our answer? You should have said check for extraneous solutions. So that is what we're going to do now. So x equals 26, we have to do that option. And then we also have to do the option for x equals negative 38. So I want you to go ahead and push pause, check both of those, and then push play when you're ready to check. All right, go ahead and check. You should have gotten that both of them are true. Now I want to point out for these, my first step when I filled it in, I did the 2 times x and just wrote 52 and negative 76. And then when you're simplifying this, you have to actually use that rational exponent and take the cube root of the 64 and negative 64 and then square it. So you should have gotten 13 equals 13 on both sides, which means both solutions work. Now you could write either x equals 26 or x equals negative 38, like how I wrote it. You could do it in the fancy little squiggly brackets. You could write x equals 26 comma negative 38. Any of those ways of writing the answer is fine, just as long as you have both and you showed that you checked for extraneous solutions for both and showed they were both true. I do want to really stress this, because when you take quizzes and tests, if the directions say make sure you check for extraneous solutions and you don't show that you checked it on your paper, you will lose points. So absolutely make sure that you are showing that you plugged it in and solved. Alrighty, that is the end of our notes. Have a good rest of your day.